Okay, welcome. We are going to be making equations of these graphs. So this is a trig function graph of the form y equals a sine or cosine b theta. And this here could be a theta right there. But we're going to be making the equation of this based on the info that we can see here. So I go through a little checklist in my head when I do this. It looks something like, okay, what's the amplitude? All right, what's the period? What is the frequency? You know, is it a sine or cosine? Is the value of A positive or negative? So let's go through hit this. This is certainly optional right here. What is what's in this box right here is certainly optional, but it's very helpful. Okay, so the amplitude, 4. Definitely 4. The period is 12 pi. I know that because that's the amount that it takes to make one full wavelength. This is a start point and end point right there. That is one full cycle. This thing would keep going around like that. So the period is 12 pi. Now, what's the frequency if the period's 12 pi? Well, check this out. The period is 2 pi over b. And b is that number right in front of theta. Well, we don't know what b is, but we do know what p is. And something else. You can also rearrange this into a new formula that says b equals 2 pi over p. And if you're like, how can you do that? Well, you just remember that those two things are flippable, which is not a word. But if 8 equals 24 over 3, let me illustrate this with an example. If 8 equals 24 over 3, then if I took this and just switched them, I would have this. And you can see that that's still true. 3 equals 24 over 8. So B would equal 2 pi over P. So if I plug in 12 pi for P, what do you get for B? Well, the pi's would cancel, and these would reduce 1 over 6. So this frequency here would just be 1/6. Is this a sine or cosine wave? That is a sine wave. And is the A part of this going to be positive or negative? Negative. This is negative because it starts here and goes down. That's why. So we can come up with our equation as y equals, and amplitude is 4, and it's negative. So we're going to say negative 4. We know that again because it goes down and up, not like this. Okay, that would be a positive one. So it's 4 sine b theta, and b is 1/6. So it's 1/6 theta. And another maybe slicker way to write that would be y equals negative 4 sine of theta over 6. That's how you usually see it. Either one of these two things would be A-OK. Now, I have another one, and if I'm going too fast, go back and watch it again. Okay? Here's another example, though. And I'll pause this and be right back. Okay, so we get this example. Now, again, amplitude, just real fast. All right, amplitude, period, frequency. Let's try it with just those. Amplitude is 2. The period is where it ends, right there. That's 4 pi. And the frequency, we remember that the frequency is 2 pi over p. Okay, go back and watch that again if you were like, I don't know where that comes from. But that would just be 2 pi over 4 pi, which is 1/2. So frequency is 1/2. And this thing behaves like a cosine wave. So it's going to be y equals 2 cosine of 1/2 theta, or theta over 2. Okay? 2 cosine of 1/2 theta, and we can see that the amplitude here should remain positive because that's what cosine waves should look like. All right, you guys have a good one.